Okay, morning everyone. How are we all? If it's anything like a usual ACCU conference, rather bleary-eyed, I should imagine. I must admit that I didn't have a very good night last night, so I'm still half asleep. Now, this morning's session, I'd originally proposed it. I proposed it as essentially sort of a workshop. I have a few things to say on the subject, but actually I wanted it to be more of a group discussion, sort of a sharing of experiences, the kind of thing that actually the ACCU conference does pretty well, at least I think. And anyway, but obviously, we're not in that particular world at the moment. So I'm just trying to make sure I can see the questions and answer window. So there we go. Anyway, but more of that in a moment. The other thing that sparked the idea of doing this was some work I was doing last year. Well, because I originally proposed this for the 2020 conference, and some work I was doing at the time on this library, GetDNS. If, as is hugely probable, you've not come across it, this is a C application library, which has some rather good, certainly Python, and I'm told no JS bindings. I've never tried the latter. And it lets your application make DNS queries synchronously or asynchronously, but with full support for all forms of modern DNS usage. So it can do DNSSEC validation. It can do DNS over TLS, and very soon it'll be able to do DNS over HTTPS. And it lets you look at all the details of the data that comes back from the DNS server, which can, under some circumstances, be useful. Anyway, I was doing two things for GetDNS. And the first of them was that the build system that GetDNS was using at the time was good old-fashioned, if I can put it that way, Autocomp and Automake. Sorry, right, okay, chat window. Found the chat window, thank heavens. And now GetDNS is available for Windows, but the way they were building, obviously, if you're using Autocomp and Automake, that doesn't run natively on Windows. So the Windows build involved quite a lot of min-GW magic. And one thing I wanted to do, and I chatted about for some time, was converting the build to CMake so that we could have instead CMake producing a Visual Studio project. And in fact, these days, Visual Studio does support CMake to a certain extent. So we could have a proper first-class build on Windows using the native Windows toolchain. And the other thing I was doing was that, as I've said, GetDNS includes support for DNSSEC and indeed DNS over TLS. And that was written using the OpenSSL libraries. And we had funding from a group that wanted to provide that functionality using GNU TLS instead. They didn't want it was interesting. They didn't want a full support, but they just wanted most of it to be supported by GNU TLS. I think it was probably for some sort of enterprise tick box list or something. And anyway, in both cases, despite GetDNS is written by a group of very experienced and very capable developers, and in no way, when I'm talking this morning about other bits of software, in no way am I attempting any kind of criticism of any of the developers. I just must make that clear. But I just found that the GetDNS developers were surprised by the approach that I took, going, "Oh, haven't seen that before. That's interesting." Anyway, so I thought I'd share a little bit about that. So, come on, mouse click in the right place. So, cross-platform development. What exactly am I talking about here? Well, I did some Googling on cross-platform, and what I learned was that, judging by the Google results, cross-platform means it runs on Android as well as iOS, which isn't actually what I'm talking about. I'm talking this morning about, broadly C++ type code bases targeting a variety of operating systems. So possibly a desktop application targeting Windows and Mac, and if I'm really lucky, KDE and GNOME as well. And I'm talking to you through a KDE system this morning. But also possibly targeting the wild and wacky world of embedded operating systems. Okay. Now, also to be clear, I'm not going to be talking about the nuts and bolts of how you write cross-platform software. I'm not going to talk about Qt. I'm not going to talk about particular build tools and particular technologies, but only about organizing your code base. Well, maybe even not that quite. If you want to check, there were a couple of very good talks on Thursday by Sebastian Thirfel and Erica Sweet, which covered more that end of how they are approaching cross-platform in their particular circumstance. And anyway, having said that the germ of the idea was put there by working on GetDNS, I then started thinking back. 20 years ago, I was working on a JVM, targeted embedded systems, and that was seriously cross-platform portable. And I'm going to talk quite a lot more about that later on. And I hadn't really thought, but what I've worked on since, which has been, well, first of all, a long period of time working on air traffic control systems that ran on AIX and on Linux, and indeed various different releases of those. And the software I've done recently, which has, generally speaking, its primary platform has been Ubuntu of one flavor or another, but where FreeBSD support has been a thing as well. I haven't actually had the luxury for the last 20 years of writing software that only runs on one particular platform. Anyway, more of that. Now, as I said, yes, we are living in unfortunate times at the moment, and we can't all be in the same room like we normally would be. And I wanted this to be, rather than just me talking, because frankly, I do not have enough to say on the subject to last for 90 minutes, which you may be extremely relieved to hear. So in many ways, what this morning is going to be is a little rant from me, and perhaps a little break, and I'm hoping a little chat as well. Now, and then I'm going to talk a bit more, and then hopefully we can have another sharing session. Now, I've talked to our video host this morning, and if you do want to talk, by all means, use the chat. But if you put your hand up, we can bring you into the Zoom. If you've got something to say, we can bring you into the Zoom. So, provided you're not sitting there in your pajamas with tea dribbled down your front, you're very welcome to join in. So anyway, what I thought was, let's start with just a little practice of this. And I just wanted to find out how many people here are currently dealing with or have dealt in the past with a code base that they would describe as multi-platform. Anybody got anybody? Say something in the chat. Oh, hang on, I've got new messages in the chat. Excellent, brilliant. Oh, yeah, hooray. And is this typically, okay, is this typically cross-platform in the sense of, I don't know, just different releases of main Windows desktop? Or are we talking sort of wildly embedded systems, very different target points? Moving a code base between platforms, but yeah, that's got a lot of the same problems. Yeah, 10 years since I worked exclusively on one platform. Oh, and definitely multi-architecture. Yeah, I'm going to come to that as well. A library for Win32 and Linux. Excellent, good. Yeah, this is kind of what I suspected, but I never thought that my experience was in any way unique. Anyway, let me get started on sort of how the world seems to go multi-platform to me. Okay, and a lot of the examples, some of the examples in here, you may think are slightly historic, and in fact they are, because they're taken from my past. But anyway, in a kind of C-like world, when you have a library and application, and you're suddenly asked to support something else, then, your initial reaction is usually something like this. An innocent little helping hand from the preprocessor somewhere, just in one or two places. And this is actually, to be honest, as far as I'm concerned, all well and good. If you can get away with just some minor interventions like that, well, lucky you. The problem, of course, is that a little while later, things start to get a little more challenging. And of course, in real life, this often ends up considerably more difficult to read because there are large chunks of code in each section, making it difficult to follow. And indeed, that was largely the situation I found when tackling get DNS. There were large source files, there were large-ish source files, where substantial sections of them, when you look closely, would turn out to be essentially, are we on Windows or are we not division. And it's not easy to follow. And of course, the next thing that happens after that, the next stage along this road, is something like this. Okay? And it's tempting to believe that I must be making this up and nobody could have done something like this. In fact, I don't know about you, but I've seen this kind of code quite a lot. And in fact, this comes from GNU Emacs from a couple of years ago, 21.2.90. And again, I need to stress, I am not bagging the Emacs developers in any way here. I totally understand how you end up in this situation. And that, in fact, is what I'm going to start moaning about in a moment. Okay. And so, you know, obviously the problem with this is quickly, what happens on FreeBSD 10? Any idea? I haven't got a clue. In fact, it's very difficult untangling exactly, for example, what would happen on AIX. And of course, so the problem with this sort of thing is, yeah, it's hard to see what happens on a specific platform. Okay. Do you even know off the top of your head if your platform has vfork or sigchild? And in some ways, one of the problems here is we're mixing decisions. You know, in that previous code section, some of the decisions we're making is based on feature availability within whatever system it is you're using, and some of it is based on what the operating system is. And of course, when you get into that kind of situation, it becomes difficult to start modifying the code in there without accidentally trampling on stuff that's working that you didn't need to touch. So there's a big question. So the next slide poses a question. Oh, good. I was about to say the next slide poses two questions, which is why does it have click to add title on it? In fact, it turns out it doesn't, and it's just the presenter mode is showing that to me. But anyway, so GetDNS to some extent and Emacs to a big extent have wound up in the same place. Why? Why does this happen? And because I kind of think surely nobody ever set out to make anything like that. How do you end up in that way? And I think, for me personally, the reason that you end up in this way is this system introspection. I mentioned earlier that GetDNS, when I started on it, used Autocomp and Automake. And in fact, you know, I didn't make the situation much better in some respects by switching to CMake. Because what it did is the classic Autocomp thing. And in fact, I had to make CMake do the same thing, which is go around and try and work out what it is your platform supports and turn on lots of preprocessor stuff. Now, if we go back in the day, a little bit more audience participation. Does anybody know who this guy is? Yep, got it in one. Larry Wall. Okay, and yeah, sorry, I like the previous comment. I like all the comments actually, but yeah, blobs where you have third-party code with build system X inside, inside another system Y, which is built. Oh, isn't life interesting sometimes? Yeah, Larry Wall, of course, these days is best known for Perl, but in fact, that wasn't. If your memory or your life, like mine, goes back far enough, you'll know that wasn't actually the first major piece of software that Larry Wall was well known for. And yes, Patch was one of them. Anybody know the other one? Any readers of Usenet News remember RN? Which I'm afraid to say I do still very, very occasionally use, amazingly enough. Anyway, one of the other things that Larry Wall was responsible for, and yeah, good, I'm glad you're too young. One of the other things Larry Wall was responsible for was something called metaconfig. which he actually used, which is used in, I think it's still used inside Perl. I can remember in, whenever it was, about 1990 or something, downloading one of the first versions of Perl and compiling it. And you run into metaconfig. Metaconfig may look slightly familiar because before building, you run a script called configure. And it asks you a lot of impertinent questions about the layout of your file system, where you want things installed, and all that sort of thing. And it goes sniffing around your system, trying to work stuff out about it. And eventually generates a make file and a config.h, and indeed a config.show, which is where it stores its settings. And this is the sort of chat that you get out of it as you go. And this stuff is still in current metaconfig. Okay. I have always really, really enjoyed the section where it goes, looks like some kind of. Typically, when I was doing this, it would say looks like it's some kind of BSD system. And then there would be this huge pause before it eventually announced, congratulations, you aren't running Unis. Unis, I never personally came across it, but it sounds dreadful. It was essentially a Unix-like shim over the top of VMS. Now, so that's, metaconfig is the granddaddy of Autocomp. And indeed, CMake has picked up the same kind of feeling about how you should do this sort of thing. Although I think it's less baked into CMake. If you've never had the joy of using Autocomp, I think you can probably count yourself very lucky. It's a most entertaining platform. However, now, so this method of introspection, my feeling, the more I thought about it recently, the more I feel that, this originates in a very, very specific world. And I'm talking about the Unix world of the 1980s to the 1990s, where you have a gazillion related POSIX or kind of POSIX compliant operating systems. I mean, you'll remember, there we go, it's not Unix, it's not Xenix, nor is it Vnix. I remember Xenix, I don't remember Vnix. Anyway, now, because the thing here is that all the targets are basically assumed to be POSIX. And POSIX itself allows an insane amount of variation, but has a lot of commonality. And so the temptation, and I think a lot of what Autocomp is trying to do, the temptation is try to determine API behavior and code to a restricted number of different API behaviors. And I think the hope is that at some point, you will move to this new Unix-like operating system and you will run Autocomp and it'll just work and you'll effectively get platforms for free. And in my experience, this absolutely never works. There's always something. I have to admit my experience may be somewhat biased by having spent a lot of time with AIX, which manages to be subtly incompatible with just about every other Unix on the planet in various highly entertaining ways. And even in, like, there is one specific case of a reliable multicast library I worked on for a while because I needed it to work on AIX and that wasn't supported, where AIX used the same POSIX API as Solaris, but it needed it to be used in a slightly different way. And the way that the Solaris code was written and the way that you had to write the AIX code, I ended up with AIX code that also worked on Solaris. But both the ways were totally legal according to POSIX, except the Solaris version didn't work out of the box in AIX. And my other critique of this is that really this also assumes, of course, that your target system is the same as your host system. Now, admittedly, if you're running in a cross-compile environment, you may be able to do some introspection that tells you something about the target, whether you have particular libraries available, possibly. But it'll never be able to tell you about runtime behavior. And quite often, some of the tests in an Autocomp scenario are about runtime. But really, I guess my main feeling is that, yes, as I said, this was written for a very specific world. And is this our world? Oh, yes, the linker on AIX. And AIX, how AIX does dynamic libraries. Oh, please, no. It was written for a very specific world. And I think that world's gone, basically. And not only has it gone, it's been going for a long time. Fans of Verity Stop, if you've never come across Verity Stop, a columnist in the long defunct .exe magazine who still sometimes pops up on the register. And in November '96, Verity wrote to celebrate the first decade of .exe. Verity wrote a series of predictions for what might happen over the next 10 years, which included this one. 2001, all flavors of Unix finally converge on the Linux standard. And basically, I think this is largely true these days. The number of Unix variants around has shrunk enormously. I know AIX is still going, but certainly the last time I worked on it, I get the feeling of dead man walking in terms of the versions of software available for it, and so on. So essentially, my contention is that introspection is harmful. And in fact, in the real world, you either know the platform you're building for or you don't. Now, suppose that you are using introspection, you compile and build, and it works. Now, is this chance? Or is it because you're using a supported and tested platform? So my feeling is that, yeah, introspection may save you perhaps some initial porting time, but then you'll pour an enormous amount of work into maintaining the introspection mechanism. And at this point, I have to say that, yes, I confess that actually a couple of the systems I've done recently, I didn't take introspection out of GetDNS when I moved it to CMake. And the program I'd worked on before, oh my God, I did actually use Autocomp, and it still uses Autocomp. And possibly the reason for the first one is, well, a certain amount of autopilot, but there's also political stuff going on here. Autoconf, please mind my clock. Autoconf, in the world that I move in, anyway, so essentially the Unix-based world, has a major hold on developer mindset. People see a configure script and go, oh, I know where I am now. And yes, I agree that there are degrees of introspection. I'm being deliberately somewhat provocative here. And I also feel that actually what I prefer to see is a declaration of what exactly it is you're targeting, and that works or it doesn't work. And if it works because someone has done it and tested it. And there's one other aspect to it. This is an old one. If you look at Scott Adams' email address in the bar, you'll see he's got an AOL email address. Because my other criticism of this way of going about things is, as I said, on GetDNS, with an Autocomp build, they had a Windows build. To build on Windows, you basically had to, well, install all of MinGW. You had to use the MinGW GCC. And you had to put a certain amount of prayer into it. And I forget the details, but I'm not sure that you could actually successfully link between the MinGW library and a Visual Studio project. But basically, my feeling about this these days has probably shifted in the last few years. But I now kind of feel, in a way, that a program isn't really portable if you can't build it using the default build system for the target platform. Now, I'm not quite sure whether I'm being reasonable here, to be honest. The feeling that, particularly with an open source project, that, the poor innocent Windows developer who wants to build and use some software should not effectively have an entire foreign development environment and operating system imposed on them by the library author. Or rather, I mean, I quite appreciate that, sort of a lot of people don't want to be spending an enormous amount of time porting their stuff to Windows. But I think the attitude that there can be a sort of attitude that says, well, that's their problem, and if we can only make Windows look enough like Unix, the whole problem will go away. And I'm just a little bit uncomfortable about that. And my question here is, what do you think about this? Is it acceptable for anything that you might regard as production software running on Windows to not be able to build it on Visual Studio? I mean, obviously there are contexts here. And are there any other common cross-platform practices that you find a bit uncomfortable and a bit worrying? Anybody? Yeah, absolutely. Not really acceptable, but sometimes endurable. I like that. I like that. I don't know about you, that I always think that sort of Windows and Unix development, they both kind of exist in really very different cultural universes. Just in terms of the philosophy of what's going on inside the operating system, how you're expecting libraries or whatever to look. Anyway, so is at this point, obviously, if we were all face to face, that I would be hoping we'd all have a big chat about it. Yeah, exactly. Thank you, Simon. That's exactly the kind of thing I'm thinking about it. When essentially you're putting, you're blaming bugs. You end up blaming bugs on the platform not being what you want it to be. Whereas actually that's not the fault of the platform. It's trying to be what it wants to be. So, I was talking to a friend of mine recently who has done a lot of embedded system work and still does. And he was making exactly this point. Trying to make software work on Windows where you know, for example, he was saying the instance he gave me was a piece of software he came up against once many years ago, which used execver. And yeah, he kind of had a Windows library that, well, there was a Windows system that there was a Windows system that said it supported it, but you know, it kind of worked and sometimes it kind of didn't. Anyway, yeah. Right. Yeah. Okay. Yeah. Thank you, incidentally. So, CMake can be tamed for cross compilation. Open Embedded does so. However, the CMake files need to be written in a way that allows that. I've had to submit changes to various projects to make them use GNU install viz, for example. Now that's interesting because I've had to do the same as well. I mean, Meson does better. Now that's interesting because I've looked over Meson, but I've yet to try and use it in practice. More of that. Anyway, that was the first part of my things that make me unhappy about how cross-platform in some contexts is often done at the moment. What I want to do now is move on to describe essentially sort of how you go about avoiding the problems of essentially preprocessor hell. So we need to try and bring a bit of order. if we're going in that direction, we need to try and bring a bit of order into everything. And in some respects, this involves a certain amount of stepping back and thinking, and in particular, for me, getting some terminology clear. Okay, and I want to distinguish between targets here and build variants. Okay. So a target is something, some aspect of the system you're building. You know, it may be a distribution table, it may be the documentation, it may be everything. It's distinguishing different things that you build within within a single end system. Build variants are things that affect how what you build is built. So the classic variants that everybody runs into are debug and release with debug. But variants are also questions of what library are you using to implement a particular piece of function? I've already mentioned GNU TLS or OpenSSL in the context of GetDNS. GetDNS also needs to use a domain name, pardon, internationalization library, libidn, which comes in libidn or the later reboot libidn2 flavors. Or possibly, you know, are you in an environment where you're building a demo version or the usual version, or you have the enterprise version, which takes 5 times the amount of memory and crashes every 3 minutes? So a variant is something that affects the build product content. And a particular build is a combination, is often a combination of variants. So, you know, we could be talking a release with debug information that uses GNU TLS and not OpenSSL, for example. And because the variant affects the content of the compiler output, then I strongly believe that the variant combination should always build into its own unique directory. So there's no prospect of accidentally picking up an object built for one variant and trying to use it in the other variant. And indeed, I've gone so far in the past as to pick an entire build system just for this particular property. I don't know about you, I'd be interested to know, when I'm working on cross-platform software, I'm very, very often working from the same source tree. Be that either I'm using the same source tree and just specifying a different target and running the build from the same directory, or often these days I find myself using NFS shared file space with the source in it, and creating specific build directories. And so if I'm running, say, an Autocomp configure, these days, often as not, I'm going configure ... running it into a distinct build directory. And so, yeah, you can argue, I mean, I've worked with a lot of systems where essentially the path of the unique variant directory, the directory for variant output, was generated. So you had to go looking for your output in, a directory called Unix/Linux/Red Hat/ something. And whereas these days, because that actually is a bit of a hassle. And as I said, these days I'm tending to create my own directory for a particular purpose. So anyway, yes, so Docker may indeed have shifted the issue. Can I confess at this point, I've never actually used Docker. Bronek, by only working on Linux and running a VM on other platforms. Yeah, that's actually, I do quite a lot of that myself. So let's have a stop and think for a moment a bit more about how targets differ. So what might actually be a variant? Well, obviously there's the base operating system, the operating system you're targeting. There's the processor architecture. I've several times worked on systems where we were targeting a particular operating system, but using different processor architectures. You might be targeting a different GUI. I only worked on one system that did that. That tends to be a bit more interesting. You may be using different tools, and runtime libraries. We've already covered the libraries that you're using. But you may be building with Clang or GCC, or indeed VLC, the AIX compiler, if you're on AIX, or maybe you're using the Intel x86 compiler. Facilities. What I mean by facilities is questions like, does your target platform have a file system? If you're in the embedded world, things get a little bit variable in that direction. And versions. And what I'm thinking here is, are you targeting Windows CE 2.10 or Windows CE 3? There was quite a difference. And yes, Brian, thanks. Yes, different versions of runtime libraries, absolutely. Building for different CUDA versions. I spent a lot of time working on Windows CE systems, and I always think it was named Wince for very good reasons. But at any rate, also, next question, how, and of course there may be other things as well that are actually variants for your specific situation. The next thing you have to think about here is just how bad are you expecting your portability problem to be? One of the very interesting things in GetDNS is that Autocomp checked for the presence of these include files. Now, I don't know about you, these are all, standard header files. And frankly, I don't know about you, but I have never, ever met a C system. I started writing C code in about 1984, and I have never met a C build system that didn't have stdio.h. And if what you're targeting, like get DNS, if what you're targeting is essentially, it's real, mostly desktop operating systems, I really don't think you should be worrying about whether you've got stdint or not, or stdlib. If you haven't, you've got much bigger problems. But actually, I don't know about you, but I see this sort of thing in Autoconf a lot, checking, it's possibly in older code bases, but checking for headers or libraries that are mandated, or indeed compiler behaviors that are mandated by the standard. Now, in some respects, this is understandable. Okay. Incidentally, you will probably recognize the sketch, the Four Yorkshiremen, which people tend to say, oh, it's a Monty Python sketch. Yes, Python did it, but it originated before Python, not the 1948 show. Now, it's true that back around 2000, you couldn't really rely on an embedded system development kit having anything that really worked. Here we go. Yeah, stdint.h is the only one that's recent, and that's about 20 years ago. Absolutely. And Autocomp complains if you use these headers and don't have checks for them. Yeah, that's probably why. So why is Autoconf doing that? Well, I know why Autoconf is doing that, because that's what I'm talking about now. Yeah, it is certainly true that in those days, embedded system development kits were of a quality that could probably be described as truly appalling. But I'm told that these days that's really not so true. And anyway, yeah, that was specifically operating systems for, embedded operating systems that were really wild and wonderful. And anyway, if you're working on a desktop app, then you're going to be on something where I think you can actually rely on stuff required by the standard being there and actually working. Right. Okay, so that's the first part of what you can. What's a sensible thing to check for? You need to kind of scope the problem. How big a problem is it that you're going to have and that you're going to try and tackle? Now, to bring some order to everything here, typically I don't know about you, what I end up doing, what everything I hope ends up doing, is hiding behind internal APIs. Okay, you have some function that needs doing. Let's say that it's calculating some kind of encrypted hash, for example, and you want to do this using either OpenSSL or GNU TLS. What you want to be doing is abstracting out the function that you want into an internal API, and then having two different implementations of that API depending on your variant. And you want to place those different implementations. Well, you can either put them in, sort of differently named files. I prefer to put them in different directories. So something like this. Okay. Now, of course, the scope of your portability problem will define the scope of how big your API has to be. Now, as I've said, back in 20 years ago, I was working on a JVM that was wildly portable, and they actually had to have an API, internal API, that covered the entire standard library, because you couldn't rely on having strcmp implemented correctly. Now, mostly, in fact, what you'd do is you'd call some internal API, which was just a preprocessor define. This was, largely C and indeed C++. But anyway, so the idea here is that you have code that's common to both ports, you stick under common. When you need to, here in this example, perform some I/O, you call a defined API, which has separate Win32 and Unix implementations, and you do a bit of build file, build system juggling. And this is a bit better because you can see at a glance how a particular I/O is done for a particular platform. Okay. And yes, yeah, I found that approach also useful for unit testing. Yeah. And quite right. They're different concerns, but they just align on implementation. Now, this is what I ended up doing in GetDNS. And the germ of this talk was when the lead GetDNS developer, a very experienced and very good developer, looked at me and said, hey, wow, that's an interesting idea. I've never seen that done before. Well, gosh. Now, I noticed at this point, I've been talking for 50 minutes. Okay, I'm going to talk a bit more about following this approach. But in the meantime, I need a little rest. Well, I would just like to be able to finish the cup of tea that I didn't quite manage to start. Let's carry on with looking at a source code layout like the one you're looking at the moment. But how well can you make it scale up? And to go back to that, we probably need to start thinking about the platforms that you're aiming at. Okay, that example we were talking about Windows 32 and some sort of generic Unix. So how do platforms differ? Well, you know, you have different operating systems, different processor architectures, different GUIs, different build tools and runtime libraries. And hang on, yeah. This is the stuff I've been covering as variants. So one way to think about this is platform differences are just a specific example of variance. And the other thing that we really probably are attempting to do is have a mechanism, is to aim towards exploiting all the commonality that we can. So where can we look for commonality? Where are the things that we might find code that we can share across platforms? Well, it might be the base operating system. You know, you may be dealing with FreeBSD or Linux, but hey, actually, they're both Unixes, and Unixes are members of a family, which in the past was a large and dysfunctional one, but they had something in common. Processor architectures often run in families too. So, for example, I worked on a system which was targeted at some Hitachi processors, SH3 and its successor SH4. And an SH4 target can use a fair bit of code appropriate to an SH3. You may well be targeting a GUI. And some GUIs, particularly the cross-platformers like Qt, aren't necessarily tied to a particular operating system. The same things for build tools and compilers and so forth. You may have issues with particular versions of GCC. I've run into this, where you need to handle something slightly differently between, in this case, it was a GCC2 and a GCC3. And the problem with the subdirectories idea is that it's difficult to exploit these commonalities, or indeed any kind of commonality outside core all-platform code, which takes me on to the last thing that I want to talk through, which is going back 20 years. And 20 years ago, where's my mouse gone? Come on. Next slide, please. Thank you. 20 years ago, I was working on an embedded, a JVM, Java Virtual Machine Targeted Embedded System. It was produced by a company then called Insignia, and the product was called Geode. And at one point, to celebrate some milestone or other, which I have long forgotten, they gave all the developers a little piece of rock, geode with a G. I still have it sitting on my desk. That's a picture of it underneath. Insignia's previous product, incidentally, was one of the first run x86 on your Mac in the days of 68K Macs. It was which worked by doing on-the-fly compilation of x86 to 68K code. So a JVM for them was the natural kind of next step. And their approach is what I'm going to call, well, what I've called here target hierarchies, which was very silly of me because I should have called them variant hierarchies because that's what they are, and I've screwed my terminology up. Okay. And I've also screwed the reveal, so let's go through this. So the core of this technique is to specify the attributes of your target. So by this I mean the variants to the build process. Okay, so the actual set that you have will depend on the application, and you then arrange the code in a tree that follows that classification. Okay, so in this particular example, you'd have an OS tree, and under the OS tree you'd have Win, and underneath Win you'd have CE, and then possibly a specific version. And you specify the variants, target attributes, variants, I beg your pardon here, to the build system as a hierarchy. Okay. And then the build system, which back in those days, they'd written a specific makefile generation tool, would search for a target-specific version of each particular source file that you specify. And it would search all the hierarchies in a defined order, where the most common implementation, the implementation with the broadest reach, would be the last thing you'd search. So you're basically doing a depth-first search. And for each hierarchy, if you didn't find a file, you drop the element on the right hand and you try again. So more specific code that was more specific to a particular version, operating system or version would be further down the tree. Come on. Next slide, please. Thank you. So, taking a concrete example, considering the above tree, and these three settings that you're looking for source for. So our build needs to find and build io.c. So in the first example, we append the setting win/ce/210 to the tree suffix os, and then append source.io. This gives us a path, and look, there is actually that file, so we use that. If we try it again as win/ce/3.0, we do that. And no, there isn't one. So we remove the right-hand side and get the generic Windows CE implementation. Brilliant. And with the last the last one, Windows 32, so this is an old one, yeah. Again, we're trying the right-hand. We're trying the longest version. It's not there. Reduce it by one. It's not there again. Keep going until eventually you end up with the most generic. By some miracle, we have something that vaguely works for a lot of Windows type systems version. Okay. And the same applied to toolchains. Exactly the same mechanism. We're looking here for a header file that includes typedefs for types used in our application. And this is incidentally from pre-C99 codebase, so you didn't have stdint available, and you were looking for some type defs of ints that were 32 bits and that sort of thing, and using exactly the same process to look for the appropriate include file, and indeed taking this to the build process itself, the file that described what files that you wanted to include in your build was searched for using the same mechanism. Okay, And in this case, what you'd often find here, no, I'm going to come to this later, but in this case, what's happening here we have a file that does I/O for everything, and we have one specific interface. With no counterparts outside the Windows subtree, and that file will get pulled in. No, I'm making a hash of explaining this. We'll come back to that later. Anyway. So, of course, now often you have specialized requirements that depend on a combination of your variants. And so the depth search technique also worked over a combination of different variant types. Something like, next slide, please. There we go. That's better. That. So here we have an implementation where we have specific code for all Unixes, and specific code for all Unixes that run on x86, and then specific code for all Unixes that are Linuxes, and then specific code for all Unixes that are Linuxes and running on x86. And there would be a defined order in which you would combine different types of variants. Okay, how you order them is actually up to you, and it's largely a matter of taste. I mean, for example, you have a choice between adding processor architecture to the OS subtree, or you could do it in reverse. You could have the OS under the architecture tree. Now, in both cases here, I've put the toolchain on the right-hand side because I think it's kind of a specialization of what comes before. But that's a personal taste thing. The only thing really here is that you want just a defined order so your developers don't have to go looking in unexpected places. And you don't have duplicate locations where things could turn up. So you'd end up with source hierarchies like this, architecture and toolchain, where you're searching for more specific up to less specific. Again, so this actually is a remarkably successful approach to doing stuff. And yes, you're true. It's very much easier to do. Sorry, Mike. Yes, it's much easier to do with headers than with source files. Get your include paths right, and the compiler does the rest. Oh, I didn't know that. It's been a long time since I looked at the glib source tree. Mike says the glib source tree is arranged rather like that. Now, when I've talked about this before, people have often said, "Oh, brilliant, Jim. Okay, what tool can you give me to do it?" Well, to dig out a very old joke, there was once a group of mice that were being troubled by a cat, and the cat was causing them constant danger. And so the mice went to the local wise old owl, and they asked the owl, "What can we do about this?" And the owl said, "Well, that's easy. You need to tie a bell around the cat's neck so that you can hear when the cat is coming." And the mice all thought, "Brilliant," and went away. And then came back later and said to the owl, "Owl, how do we get a bell round the neck of the cat?" And the owl said, "That's not my concern. I am a policy-making owl." And I'm afraid here, I am a policy-making owl. There's a few approaches spring to mind. You could have perhaps some sort of pre-make stage, and if you're using GNU Make, you could get stuck in with vpath. You can try some sort of makefile or other build system generator, or you can adapt a build tool. I'm coming to think these days that build system generators like CMake and Meson, I'm coming to rather like them because, going back to previously in the talk, it gives you the possibility of being able to use tooling and IDEs appropriate to your target platform. And as I've said, I'm kind of beginning to think this is more and more of a good thing to do. Some of you also may be worried on the potential impact on overall build time, because you do potentially have a huge number of target source directories available. And but actually, this isn't a problem, because although you have a huge number of potential target directories available, your actual number of target directories is a lot more manageable. And so what happens, certainly in the Insignia generator, is it would generate the complete list of potential directories. But as it was generating them, it would be it would first compile a list of the actual directories that were present. And when it generated them, it could combine the two, because of course generating potential directories is a very fast sort of little string manipulation. It could instantly chuck away the ones that didn't really exist. And the impact on build time of running this pre-make stage, this is a build time that if you're doing it from scratch was something in the order of 20 minutes or so when I was working on it. Before I turned up, things had been much worse, and it'd been well over an hour. Running that makefile generation typically took something in the order of maybe half a second or something, if that. These days, it'll take no time at all. But really, what I want to do now is step back for a moment. Okay, John, thanks. This is similar to how Unreal Engine now structures its various cross-platform sort. Much better than the previous if-def catastrophe. Absolutely. One of the advantages of the Insignia system was that your portability could evolve. And in fact, actually, I think that's a very good starting point for doing cross-platform portable stuff. Plan to accept that you're going to it's going to evolve over time. You're going to have to be prepared to refactor code. And the way to do things is generally to write code at the leaves. And then when you've identified commonality, you start pushing stuff up the tree. And to some extent, this makes it easier to identify sort of portability related work, because if you're working on a new leaf, it's because you're working on a new platform. The other crucial thing that Insignia had was regular automated build and test for all platforms. When you screw things up, you want to find stuff quickly. Okay. And when you are targeting a range of target OSs, it becomes somewhat impractical for developers all to have access on their desktop to 5 or 6 different target environments. Typically, what would happen at Insignia is you'd build it yourself for a couple of platforms. You'd typically be working on one particular port, so you'd build that port, and then you'd build the Windows x86 and the Linux x86 build, just to make sure you haven't screwed things up too badly. And just as an illustration of what of how well this process can work if your problem fits this way of working. The Insignia JVM had 5 AWT, that's the windowing toolkit, 5 AWT flavors, including none, 7 Java version flavors, 12 OS targets, 3 toolchains, 2 JVM types, and 5 major CPU architectures, and there were no poor if-defs anywhere. Which, frankly, I think is a bit of a result. And I've talked about this a few times since, because I think it was a really nice way of approaching the problem. But it's obviously one that a lot of people haven't come across before. But finally, I think my 2 key points from this are just simply that exploit commonality whenever you can, but you have to give yourself a mechanism by which you can exploit that commonality without compromising, without compromising the details of particular port. And the second thing is, I really, really feel that the build system needs to be your servant on this one. And it needs to be part of your development project in the sense that you must have license to work on the build system as part of your development. It's why I'm somewhat leery of build systems that are too closely tied into particular IDEs, because I do feel that often with build systems you just need to be able to tweak them to exactly what you need. Right, well, I think after an hour and 15 minutes, even with a break, that's quite enough for a Saturday morning. So I hope I've helped your morning pass without too much pain so far. Thank you all very much for turning up. I wish very much that we could be a bit more interactive about all this. As I know from being at the conference so far, it's not easy sort of sitting there just letting somebody talk at you, and I'm sure you'll know as well that it's equally difficult firing stuff out into the void. I will go and lurk in Remo at this point. If you'd like to come over and say hi and abuse me for wasting your time this morning, I'd love to see you. So I will be, let's find an empty table. I will be on level 2, table 8. There we go. Thank you very much. If anybody's, yeah, I would say feel free to ask questions in the chat or whatever. Arno, what was the final solution for your DNS library? I don't have a final solution at the moment. I know what I would like to do. And the question is whether I would actually be allowed to do it, because it would scare the horses, I think, and it would change the build system. And unfortunately, the way you go about building, and unfortunately, the library is now in a state where it is being packaged by third parties. And so every time you change how you build it, that impacts on those third parties. Now, we did manage to just crash through the whole change from Autocomp to CMake. I personally would like to actually sort of stick with CMake for doing the build, but just rip out all the introspection and just make people specify a target, or possibly use CMake, but only use CMake to determine your platform and continue with the target platform equals host platform assumption. Anyway, so thank you very much, everyone. And I'll say goodbye at this time and hope to see some of you over in Remo in a moment. Enjoy the rest of the day.